Chunlin Liu. I'm happy to welcome Chunlin Liu from our department. The title is Regional Mean Sensitivity in the Maximal Mean Equicontinuous Factor. Please.
Thanks for the invitation. Today I will give a talk named regional mean sensitivity and the maximum mean continuous factor. This is a recent work, advanced work with Till Hauser. Now he is a postdoc at Chile. First, I want to show a roadmap of my talk. The main question is, could we find a right proximal type relation describing the maximal mean equicontinuous factor? This question motivated by characterization of maximal equicontinuous factor. I will show the following. We know the maximal equicontinuous factor is used by a relation called the regional proximal relation. So in this talk, we also found a mean variant of this thing to characterize the maximal mean equicontinuous factor. And this work, I think the first job is it was by Qiu and Zhao, and based on their paper, Li and Yu put a relation called the weakly sensitive intermean relation, and this group use this relation can characterize the maximal mean equicontinuous factor for the action. In this talk, I will show we have a concrete example. It is a non-Abelian amenable group, and indeed it is a left-right group. And this group action, we have a system. It has this system's weakly sensitive intermean relation is not empathy, but this system is F mean equicontinuous. So from this factor, we know this relation cannot work for the non-Abelian amenable group, and then we will refine the relation. And through our main theorem is, and the main theorem is our relation can be used for work for all the amenable groups. And first we recall some notation and definitions. Action of G on a compact metric space X is a continuous group homomorphism from G to the homomorphism map from X to X, and we will abbreviative Gx equal to alpha Gx, and write Xg for an action. And this is a very usual example. It's a Z action, and H is a homomorphism from X to X, and then it can induce the Z action by N map to H to N. And now we record the definition of equicontinuous. An action Xg is called equicontinuous if for all epsilon is the zero, there exists delta is the zero, such that for all x prime belong to x prime with the distance x distance between x and x prime less than delta, then we have all the orbit distance along this group is less than epsilon, and we can see a picture. We give 2 points x and x prime. So we can see the orbit x and the orbit x prime. The equicontinuous, it means every step the distance is it cannot be very large than the epsilon. As an example is all the Abelian group rotation is equicontinuous. And in this talk, we focus on the G is the comfortable group. So Fauna sequence is mean a sequence of the non-entity finite subset of G. It's called fauna if this set translated by a G is not changed too much related to the original set Fn, and so this means this limit comes to 0 for any G. And example is the C is has a standard for the sequence is the finite set from 0 to 1 n minus 1. You can say for any n plus fn, set minus fn, and divided by fn is convergent to 0 when n to infinity. And a group is called amenable. Group is for it follows from a sequence. And there are some examples. If any abelian group is amenable and the solvable group is amenable, but the free group is not amenable. And in this talk, we have a standard assumption. If nothing else is mentioned, Xt is the action of a countable amenable group on a compact metric space, and B unites a continuous matrix on X. And now we can try to give the definition of meaning equicontinuous. First, we give a definition called F meaning pseudometric. Let F be a Fauna sequence. The F meaning pseudometrics be given by the sum of the orbit along Fn and takes the average. Then let n comes to infinity. And we will see the df depends on the choice of a Fauna sequence. We can see an example. When we consider the section, we use the standard Fauna sequence 0 to n minus 1. We can see this we can see the picture. The action is this ray is this point, and the action is this and this along this direction. And if we consider the x prime and this Fauna sequence, we can see along the Fauna sequence the distance will smaller and smaller. So this matrix will converge to 0. But if we consider the converse direction, the Fauna sequence minus n minus 1 to 0, we define this to the matrix. We can see the distance is bigger and bigger. So this matrix, so this matrix is not 0. So we can see the matrix will depend on the choice of Fauna sequence, and the definition of mean equicontinuous is action Xt is called F mean continuous if this pseudomatrix is a continuous function on the xy space, and indeed this can be split by the similar method of the equicontinuous. Because if we use the equivalent data to write the continuous function definition, we will see this is similar. And this definition, I think, for the action is from the paper by the Qiu and Zhao, and for the general amenable group from Buma, Groza, and Len. And we have a remark. When we consider the standard Fauna sequence, this notation is already to coincide with mean Lyapunov stability introduced by Fauna in 1951. And we can see a picture. we can see the 2 point x prime is similar to the equicontinuous. We need most of time the distance is not it cannot be very big, but we can allow sometimes the gap is large.
So is this non-trivial that this is equivalent to continuity, because I don't see the relation. There is the natural definition with the mean.
Yes.
But then you said you gave a definition using continuity.
Yeah. Because yes, from the continuity, if we use the Qiu and Zhao language to write the definition of continuous, is for any Qiu there is a delta x and x prime. The distance less than delta, then the pseudo matrix distance is less than Qiu.
Okay.
So it's only for simple to state. And we just say that because the distance is depends on phonotypes, and indeed this definition also depends on phonotypes, but the notation is independent from the choice of a continuous matrix. And from the Human length from UPG is abelian, and XG estimates environment is possible, especially if XG is minimal satisfied this condition, then F mean continuous is independent from the choice of the phonotypes. But in general, F mean continuity it depends on the choice of F. And now we want to consider the maximal mean continuous factor from the Alice source. So every G action admits a maximal continuous factor, and indeed in this paper they also consider the historical factor, and indeed they give a general method to consider some property. The action has some maximal factor with some property. We can see here. First, we give a definition of product action. This is a product space and using diagonal action. And in their paper, they give a general maximum factor per cycle. Indeed, if a property P of an action assume the 3 conditions, the 1 point action satisfies P, and P is inherited by some action. This is mean if XG has this property, and for any closed environment subset also has this property. And 3 is P is preserved under the conformal product. Then every G action admits a maximal factor with property. And in their paper, they prove equicontinuous K and distal satisfy these 3 conditions, so it admits a maximal equicontinuous factor. Oh, and then we will give a relation. It can because we know closed and environment relation can induce factor map, and this is 1-to-1. And we know the regional proximal relation can induce the maximal equicontinuous factor, and then we can see first is the definition. We also can see a picture. If we give a pair x prime, it's called regionally proximal. If for any issue, this the issue can be viewed as the neighborhood of diagonal, and any open neighborhood of x, there exists y and y prime in this neighborhood, and we will get g such that the gy and the gy prime will go into this neighborhood. This is called the regional proximal pair. And we donate the regional Q regional proximal X for the set of all regional proximal pairs. And I think many famous mathematicians have shown this result, but to be honest, I don't know which branch prove this, so I'm sorry. And this xg the action and the xg is equicontinuous if and only if the regional proximal pairs contained in the diagonal, and if we quotient of this relation x this quotient space is the maximal factor, maximal equicontinuous factor of xg. Here if R is a set and we donate this notation for the smallest closed environment relation that contains R. And so for the same reason, we also can check the mean equicontinuity satisfy the singulated action is F mean equicontinuous, and a subsection of F mean equicontinuous is F mean equicontinuous, and also this property brought out by countable product. And so,
excuse me, let's go back for a moment to previous slide. So here on the factor, so this QRP is it the equivalent relation?
no, generally no, but
We consider the
you can have an environment. So we need to take this.
okay, so
So we have a corollary for action xg. There is a maximal f mean continuous factor, and these people only focus on the d action, but they also use this similar method to prove this, and this method can be applied for all amenable groups. And so from this we have a little question. For equicontinuity, the maximal equicontinuous factor is described by the regional proximal relation. And could we found a mean analog of the QRPX, and it can whose quotient gives the maximal F mean equicontinuous factor. So let's the first law is for the D action. And the relation called the weak sensitive intermean. First, we give the definition of a weak sensitive intermean. For a subset U and 2-point YY prime, we denote the 18 times set of the YY prime to U is this form. And the Li and Yu give a definition for weakly sensitive intermean for the action, and from the definition also can be similar to extended for the amenable pair x prime. It is not in the diagonal. It's called F weakly sensitive intermean. If for any neighborhood of xu there exists C, such that for all epsilon there is n, and the YY prime is DYY prime small, the distance of YY prime smaller than epsilon, such that this set have a uniformly lower bound, because we need to see the C it doesn't depend on the epsilon, and then we denote this set for the set of F weakly sensitive intermean pair. And we also can see a picture of this definition. We choose this pair x prime and its neighborhood U, and also a neighborhood of diagonal. We can find a y prime in this neighborhood of diagonal, then we not only need to G such that the G y prime going to the U, we need to have a uniformly lower bounded density to go into the U. And in the papers, we prove if F is a standard form sequence in D, and XD be a direction, then XD is F mean equicontinuous if and only if this relation is content in diagonal, and also this and the X quotient this relation, it is the maximal F mean equicontinuous factor of XD.
Can you give some examples for calculating?
Example?
Yeah, of some known system and what is its maximal F in equicontinuity?
You mean it has non-trivial?
Yes.
For example, you in the non-trivial mean equicontinuous system or system?
No, just that you introduce this object, right? You say it exists always, so just to get a feeling what it is.
For example, if the system is mean equicontinuous, its maximal equicontinuous factor. Yeah, it itself.
So what would be an interesting example of such a system?
I think has some in this paper has some example about subshift, but it is a little technique. Okay. I think very well known example.
Also, for example, if you expanding for like the QF model, like on the one-dimensional torus, and you come from QX model, this special expanding system.
But this is with the mixing.
And it's so its maximal F mean equicontinuous factor is trivial.
Yeah, I see.
And is that possible to give it a maximal over the set? Because you already showed that there are possible like two ways of maximal mean equicontinuous factor, but can you get a maximal over like all the quantities?
Yeah.
It's
Also, in our people, we also do this. If you mean if along the F, we call the F mean equicontinuous.
Yeah, and then over all the
Take all the F, we call the mean equicontinuous. And in order to give an example, to show the definition, for the weakly sensitivity is not enough for the non-Abelian group. We need to provide some characterization of these things. And first, we introduce a definition called a sequence xn, xn prime belong to x22 is called a asymptotically diagonal whenever this sequence converges to the diagonal. And in our paper, we can prove for x prime with x is not on the diagonal, then x prime belong to is f weakly sensitive in the mean pair is equivalent to for any open neighborhood U of x prime still exists a asymptotically diagonal sequence such that the following limit is bigger than 0. And then based on this, we want to give a characterization by environmental probability measures. So we call some definitions. Blair probability measure mu on x is G environment. If the Hoback measure of mu is equal to mu, that is for any Blair set, the per image of A measure is equal to its measure, and we write the MGX is the set of all G environment probability measure on X with the V star topology. And we also call giving a F for a sequence, and X is a sequence in X5. We can define the empirical measures on F22 by this form. This is a direct measure at the point gxn and gxn prime and take sum and average each mu n. And we denote by the MFX the set of all the V star cluster points of this sequence. And it is easy to check this set the content in the environment measure, the set of environment measure on the X5. And we record this definition. Then we can see if x prime belong to this is a weakly sensitive intermean pair is equivalent for any open neighborhood x prime. There exists a simple particular diagonal sequence, and a measure mu belong to the just set such that the mu u bigger than 0. And this proof is not difficult because we know the measures convergence in the V star topology is convergent. It means for the integral of any continuous function is convergence. But and we also know the matrix on the X square is continuous. So the convergence and the convergence of the measure is similar to the convergence along the distance of the average. Yeah. And now we can give a simple example. But this is I think is a simple example for understanding our construction. First, we give x be a one-point quantification of V, like this picture, and the infinity is a fixed point, and the action is from 0 to 1, 3, blah, blah, and the inverse is like this. And from this system, it's easy to check the environment measure. It's only the Dirac measure at infinity point, and so the environment measure on the X square is also only have a Dirac measure. And from our results, we know this pair must be impeded. It's an impeded set, and so Xz is F mean continuous along any for the sequence. And based on this, we can construct an example. It to show a weakly sensitive intermean relation is not enough for the non-Abelian amenable group. And this example, like just example, we only copy it. And on any copy, we use the same action, sigma x is x plus 1. And then we need another action is change the because for the upper copy we call the 1 up and the down we call the 1 down, and this action is mean we change the B up and B down position. Like this picture, we change the 0 down, 0 up to change this 0 up and 0 down position. It is tau 0. And like this, we only everything is fixed, and we only change the 1 up and 1 down. So this is tau 1. And now we have these two actions. And for convenience, we give a notation is tau b. B is a vector like 1, -1, and -3, like this picture. We fix the other things, and we only change the 1 up, 1 down, and -1 up and -1 down, and -3 up and -3 down. Only change this. Then we take the group generated by sigma and the tau 0. This is the lamp-like group acted on X. And we give some a factor. Each G has a unique representation of the form to G is equal to sigma A and tau B, with A belongs to C and B is a finite subset of C. And now we consider a set A belong to the integral number, and because we know in the group Z or the form sequence has the form the interval, and the length of interval will converge to infinity. So it is not difficult to check if this is a form sequence in Z. And we can prove this thing is Fn is equal to sigma A tau B, and A union B belongs to A. This F is a form sequence. And now our goal is to show the Xg is F mean equicontinuous, but we have a non-diagonal pair belong to this set. That is, it is a weakly sensitive intermean pair. So we know for abelian group, this relation is not the right projective expression the F mean equicontinuity, and hence it not describe the maximal F mean equicontinuous factor. To prove this example, first we give some ideas. The first step, we will prove for any fixed x, tau B is invisible on X for all large N, and all B belong to AN. And hence we can reduce the average on Fn to the average on the Z action like this. And so we can prove df is equal to dA belong to the continuous function. From our first example, we know the dA is a continuous function, and in the following, I will show we can prove PF is equal to PA. So it's also a continuous function. Now we can give a proof about this. The first step, we can see, we recall the form sequence Fn is this form, and fix x belongs to x. From our definition, we know the x there exists C belongs to C union infinity. We know x is x up or x down, and then we can see for any sufficiently large n, we have s not belong to an because an is equal to the interval from n to n. So, but the s is fixed when n large enough, it not be contained in this. So, for any b belong to an, we can see tau bx is equal to x because we just see the action tau b is exchange the position from up and down, but the s not into the an, so it will didn't change the position of x, and so we can find the sigma a tau b action on x is equal to sigma a action on x, and from this observation we can say this is the definition, and because from the form of Fn, we know we can change this to this. This first step is just the definition, and we use just the observation. We know the b belongs to an is when n large enough will didn't influence the sum. So we have this thing. And we can see here we don't have the b, so we obtain the 6. So we can change the we can reduce the sum along the Fn to along the former sequence be contained in Z. And then from here we have proved the system is F equicontinuous. And the next step we want to prove this pair is weakly sensitive intermediate. First, we choose xn is equal to n up, and n prime is equal to x plus 1 up. Then it is easy to check from the picture. We can easily check xn prime is a simple triplet diagonal. And we define the we want to use our characterization just that. We define the empirical measures of x squared like this form. And we want to prove mu n convergence to passing to be a subsequent convergence to mu infinity, and give a positiveness to every neighborhood of this pair. And by the similar reason, for large n, the totality of this pair is only depends on the intersect with n plus 1, because the on this pair we only change these two things is useful, but from the definition of totality, and so we can only average over the b contained in n or n plus 1, like the computation above, we can obtain have this form, and let n converges to infinity. We know this measure converges to the 4 Dirac measures average, and we can see the infinity up and infinity down in this here. So we can prove for any open neighborhood U of infinity up and infinity down, we have the mu infinity U is strictly bigger than 0. And so this pair is weakly sensitive in the mean pair. And so we record the result for the direction. This is true, but for the non-Abelian amenable group, this is not true, not enough. So we need to refine our relation to characterization for non-Abelian group. Based on this, we introduce a notation called regional mean sensitivity. And first, we record the regional proximal relation we just said. It's for it's the x prime, and for any neighborhood, we can find y prime and g such that gy from go into this neighborhood of diagonal. But if we read the backward, we can see another shows, because we can reformulation this definition from here. Because from this picture, if we view the gy and gy prime and action on g minus 1, then we can see like the 2 point is it has a very small distance, but under the action it go to the neighborhood of x prime, but we know x prime is different pair, so the distance is bigger. So it's like a sensitive sense. And from this view, we can see the definition can be reformulation to the following: if for any open neighborhood of x prime, there exists a symptotic diagonal sequence x prime such that the number of the taking time set and let the n to infinity, the limit u is bigger than 0. But this can be used to characterize the equicontinuity. So for the mean continuity, we want to do averaging form of this. First, we record the definition for the upper asymptotic density of G prime is along the sequence. We can choose G prime content in G and intersect with Fk like this. This is called density, and we only a similar statement, but we change the number of the set to the density of the set, and we call the region mean sensitive. If for any open neighborhood there exists a symptotic diagonal sequence x prime such that the density, the limit of the density is strictly bigger than 0, and we can see the regional proximal has this form, but this is for the equicontinuity. So, but we want to consider the mean equicontinuity. So it is a natural method. We change the number to the density, and the picture is indeed similar. And we give a neighborhood of x prime and this xn prime. We can say have a positive density or a set of G such that the G xn prime can go into this neighborhood. And we denote the QRMSF for the set of F regional mean sensitive pair. And this is our main result. We can prove if we consider this relation, Fg is F mean equicontinuous if and only if this relation is contained in the diagonal. And if we quotient of this relation is the maximal F-mean equicontinuous factor of Xt.
Could you just explain the difference between QRM and QRS? I mean, what did you find before using the same feature?
Yeah, yes. Wait, yeah, we use the same feature, but the and from this definition, maybe we have is here. We can see in this definition is there exists a sequence, but the xn and fn is convergent to as the depends on the n at the same times. But in the new definition, the x this is not dependent on. We will see it for any n, and we consider the density, and density is less the upon sequence convergent to infinity first. Yes, because like here we the density, and here we fix a set and let the one sequence to converge to infinity. And then we let the n converge to infinity. And to prove our main results, I want to also give some ideas and characterizations. First, we will also call this measure is empirical measures, but it's a little different, like because here is x prime is independent of the n, but in the characterization we just said the x prime is also dependent on n. So here we also can give a characterization of these two pairs in terms of the inner measures. If x prime is a regional mean sensitive pair, if and only if for any open neighborhood U of x prime, there exists a simple triplet diagonal sequence, and mu n belongs to the fxn n prime for all n such that the limit U of the measure U with respect to mu n is strictly equal to 0. And if the 3 is the similar thing, but we can change the subsequence of the x prime to guarantee the inferior of the sequence is bigger than strictly bigger than 0, because here we only need to there exist the sequence. And the proof can be divided into some lemmas. The first is if the xn prime is a simple triplet diagonal, and mu n belong to the set we just did definition here, is weak star cluster points of the mu n. Then for all n, and then mu n is the weak star cluster point of mu n, then the support of mu is be counted in the original mean sensitive. The proof idea is if we take the x prime belong to the support from the definition, we know the mu u is equal to 0. and we can choose nk such that new nk is constant to mu, and by the postman to 0, we know this limit u is bigger than the measure of the mu u, and mu u bigger than 0, so this is bigger than 0, and from our characterization, we know x1 is belong to the it is the regional mean sensitive here. And the next observation is we can this is the mean pseudo matrix, and we can rewrite it by all the integral of the matrix with respect to all the measure in this set. This proof is also direct because this df x prime is equal, this from definition is equal to this, and we can rewrite this as the integral of c with respect to the Dirac measure, and because c is continuous, and from the definition of weak star topology, we can obtain this. And then we can prove if x can x to 1 be a factor map, and then this relation be contained in the upper definition is in the upper definition is used by the factor. Like upper is defined by x prime down to and x equal to x prime. Like this. And if the original insensitive relation is contained in this relation, the yg is f mean continuous. Yeah, and we give a idea of proof. If yg is not mean continuous, from definition, we can find yn comes to y, and the delta between 0 with such that the mean pseudo matrix is strictly bigger than that. And we just rewrite the pseudo matrix to the measure, maximal of measure, so we can find mu n such that the integral is bigger than that. And we can left yn and y to the x. This left is absolute. We can choose any xn such that xn is equal to yn and x equal to y. And then we can use the empirical measure mu n for xn and x like this. Then it passed into a subsequence. We can assume it converted to mu. And then we pushing forward to the y2, this still with the 2 mu, and we know from the second condition, we know the pi star mu n is equal to mu n. So the mu is equal to pi star mu, and then we can obtain the integral of d with respect to mu is strictly bigger than 0. But we from our assumption and the result we just proved, the support mu be contained in the regional mean sensitive in the mean, and from the assumption it be contained in this relation. So the support mu must be contained in diagonal, and this implies the integral of the mu d is equal to 0. but just we said mu t is bigger than 0, so this is a contradiction. So we can prove IG is mean F mean equicontinuous. Apply this is apply just the lemma, we can finish the proof. If the relation be contained in diagonal, apply the lemma to the pi, the factor map is equal to identity, then we can obtain the xg is f is continuous, and conversely, if xg is mean equicontinuous, we also suppose for contradiction, x prime is belong to the QRMSF with x not equal to x prime. Then we take the open set is a matrix bigger than 0, bigger than epsilon, and the epsilon we can choose the distance of x, maybe half of the distance of x prime. Then the U is the open neighborhood of the pair x prime. And from the characterization of this set, we can find a C subset and a symptotically diagonal x prime and mu n in this set with mu n u is bigger than C and strictly bigger than 0. And hence, because we just proved the df is equal to the maximal measure in this set, so it's also bigger than mu n d, and mu n d it's also bigger than epsilon c, because we can say the u is the definition of u is all the pair, and the matrix D is strictly bigger than epsilon, so its integral of D can be bigger than C epsilon and strictly bigger than 0. But this is contradicting the definition of F mean continuity. So we prove the relation be contained in the diagonal. So for the maximal equicontinuous factor, we have from this factor, because for any F mean equicontinuous factor have from x to y, one must have QRMSF be contained in this relation just said, and so because we can check this is a closed environment equivalence relation. So we take this notation is also contained in the R pi, and because the pi is arbitrary factor such that y is F mean equicontinuous, so we know this is the maximal. Yeah, so we can finish the proof. At last, we give a application of our results, and we will give a notation for G action. We denote the maximum support by this form. Indeed, this is also equal to the support of all the environment measures, the union of all the environment measures. And this support is closed environment and non-environment. And I believe this is well known. And I found a reference from the Li and Qiu. And from our papers, we can prove the regional mean sensitive pair must be contained in the this set nothing contains the maximal support. And we also have the second statement is if the this set intersect with the diagonal, it must equal to the diagonal with respect to this set, the maximal support. And from this level, we can have I think a corollary, because the factor map let XG be action, the factor map pi onto the maximal equicontinuous is 1-to-1 on the X set minus support XG. So we can see the corollary can show if we if a system the different we can say if for example if the X is not minimum, so when we consider the complexity of XG with some things, we can only focus on the support of XG because from the except this set the dynamics is similar to the F-mean equicontinuous. So because it's 1-to-1. And the comment is the result is printed also good in the context of continuous action of sigma compact and locally compact amenable groups. And thank you for your attention.
Any questions?
Yeah, just that this example is one Python group and two compactification of D. So there, your invariant methods would be only sitting on this infinity point.
Yeah. So
I'm just checking. I understand correctly.
The first example of the second, line.
We'll apply the group action on two copies of 1 point competitive.
Yeah,
Yes, yes. In this example, I mean, how your last slides apply to it. So you have the invariant measures will be just sitting on the infinity. Another invariant. Sorry, and other invariant. It's not no other finite invariant. I see. So yeah, I'm just trying to present how your last statements apply to it. So it will be just kind of trivial example in this case. So your last statements. About the intersection of this RWSM with the diagonal.
Oh, yeah, yes.
So that it will be inside this set of supports of invariant measures.
Oh, yeah. Oh, yeah, you're right. Yeah, the last.
Yes, sorry, I'm confusing.
Yeah,
Yeah, so I just try to understand how it looks like for the example of the action of completer in the group which you gave.
Oh, okay.
So support will be just the points in each, right?
Yeah. Yes, but it has two copies, so it's also upper infinity and down.
Yeah.
Any other question? But if not, let's spend Chunlin.